Welcome to Pomodoro Joe for Monday, September 18th, 2023. Today we're doing LeetCode problem. Try out. Thanks. Today we're doing LeetCode problem 1337. The leetest problem there is. This is truly a LeetCode problem. The k weakest rows in a matrix. This is an easy problem. You are given an m by n binary matrix, MAT, of 1s representing soldiers and 0s representing civilians. The soldiers are positioned in front of the civilians. That is, all the 1s will appear to the left of all the 0s in each row. Okay? A row I is weaker than a row J if one of the following is true. The number of soldiers in row I is less than the number of soldiers in row J, or both rows have the same number of soldiers and I is less than J. Return the indices of the k weakest rows in the matrix, ordered from weakest to strongest. And then we have some examples. So in this case, we have an array of arrays. So this external bracket is showing that we have one array, and then internally, every element in that array is an array itself. So let's see, in each of these arrays we have 1, 1, 0, 0, 0, so all the 1s come before the 0s. I don't think that really matters. What really matters here is the number of 1s in each row. So we have 2 1s, then we have 4 1s, 1 1, 2 1s, and then a whole bunch of 1s. So in terms of weakness, the number of soldiers is the first thing we look at. How many 1s are there? Where this row only has 1 1, so that must be the weakest row of all these other rows. So let's see, that is index 0, 1, 2. So row 2 is by far our weakest row. Okay, and so we do have that as our first element in the output. Now we have 2 1s in row 0, and we also have 2 1s in row 3. That's 0, 1, 2, 3. But because 0 is less than 3, we put 0 first, and then we put 3. All right, so this is pretty straightforward, but it's kind of tricky for an easy problem. Anyway, we'll put this to Python, and we'll put 25 minutes on our Pomodoro timer, and then we will get started. All right, now our result will be a list. Now it shows us here that our result will be a list of integers. So our result will be an empty list to start with, and we will return our result at the end. Now this result has to store the indices of our k weakest rows. So the k is here, and our matrix is here. All right, so for this one, we'll probably want to sort our rows by their weakness. That's probably the easiest way to do this. If we just could calculate the weakness of our row, and then we can sort by that weakness, then we can just return the k first rows, or in our sorted list of rows. All right, so I'm going to show you a way to do this that is going to be a little bit more complicated than they probably meant for this problem, but it's good to learn these things. All right, let's take this step by step. Let's start with sorting our matrix. So I'll have a sorted matrix, and we'll call the sorted function, and we'll pass in our matrix. Now this will return a new matrix that's been sorted by some sort value. Now we can define our own sort value here, so that's what I'm going to be doing. I'll say the key is equal to, and this is where we can pass in a function. Now this function will return a value that is our sorting value. So I'm going to call this compare. So this compare is a function. Now I haven't defined this yet, but what this sort will do, this sorted will do, it will pass in each element of our matrix to this compare function. The compare function will return a value that we will use to compare two different elements in our matrix. So let's make a compare function here. So def compare. Now this compare takes it in some element. All right, sorry about that. Had a little bit of an interruption here, so I'm going to pick up where I left off. Okay, our compare function will take in some element of our matrix, so I'll call it n. Now this n will be one row in our matrix. So let's see, we'll take in this n. Now what do we return for our compare? Well, there are two things that we use to compare. One is the number of soldiers in the row. So for this, we can count the number of soldiers, the number of 1s, in this row n. And to do that, I can just return the sum of n. Now, since our soldiers are 1s and the civilians are 0s, This will just sum the soldiers, and that will return the number of soldiers in this row. Great. So this is going to do our basic sorting. Now there's one other piece to this sorting though. What happens if two rows have the same number of soldiers? Well, now we need to know what the index is for this row. Now we're not passing the index in here. So we need some way to associate the index of the row with the row itself. So let's have a new thing out here. So for this, I will actually package our row and its index together as a tuple. So let's see, we'll have, what do we call this? I think I'll just call this rows. So for the rows, it'll be an empty array. And now we'll go through and we'll fill this array with elements that are tuples. Now a tuple is just a way to package things together. So let's see, for every index and row in my matrix, and now I need to enumerate my matrix. So enumerate will go through and return the index and the value at that index. So enumerate my matrix. So now that I have the index and the row, then my element, I'll make that a tuple, so that's just regular parentheses, and I'll pass in the index and the row. So now we've packaged these things together. It's got the index and the row, and now I'll put that in my rows. So rows.append my element. All right, so now we've kind of changed this. We're going through and repackaging our matrix as this set of rows, or this list of rows, where each row is associated with its index. So now we don't want to sort our matrix directly, we want to sort these rows. So let's see, we'll pass in rows. And now when we do this compare, well, this n in our compare is no longer just the row, it's this tuple. It's the index plus the row. So our n will have, let's see, I'll do index. That's going to be n at index 0. And we'll have the row, and that's n at index 1. So we package these together with index first and then row. So our index will be at element 0 of n, and our row will be at element 1 of the n. And so now we'll sum our row. And then we also want to include our index as the other sort variable. So what we do here is we actually return another tuple with the first element being the first thing we're going to sort by, which is the sum of the row, and the second element being the second thing we might need to sort by, and that is the index itself. Okay, this is a lot for an easy problem. Next, now that we've got our sorted matrix, we still have to get our result out of this. So our result, now this will just be our sorted matrix, but we only need the first k elements, so we slice this by using the colon operator, and we pass in colon k. Now there's one more piece to this puzzle. This sorted matrix is now going to be storing these elements, these tuples that I created that have the index and the row. Now what we return is just the index. We don't want the index and the row. So right now, this gives me the index and the row. So what I really want to do is go through every element. So let's do it this way. For element in range, actually no, I shouldn't say element, let's do index. For index in range up to k, we'll append. So actually let's grab the element, let's do this. We'll grab the element out of our sorted matrix at this index. So we'll basically be going from 0 up to, but not including k. We'll grab the element out of our sorted matrix, and then that element is the index, which is element at index 0. And the list itself, I can't use list, so I'll call it row. And that's element at index 1. So again, this is index 0, this is index 1. And now we only want to include the index in our result. So our result will append the index. Okay. And then at the very end, we can return our result. Wow, this is a lot for a simple problem, for an easy problem. Let's run this and see how we do. Okay, so this works. but it's going to be slow because we're doing a lot of work in here. Let's run this, see if we can pass all the tests, and then we can come back and clean it up. And we pass. And we do pretty well, actually. Wow, we're beating 95% for runtime and 70% for memory? That is shocking. All right, we are beating 95% for runtime and 70% for memory. I don't even know if I can improve on that. So I was going to jump back here and see if we could do some things to improve. So I'm using a lot of these helper, excuse me. I'm using a lot of these helper variables just to explain how we do this problem. Now we could eliminate some of these and it might help us, but honestly, 95%, I'm surprised it worked that well. So let's see, what could we do? Well, one thing we can do is we can unpack this element directly. We don't need to do this separate indexing. So we could actually say, let's see here. We can immediately just unpack this and say this is index and row. And we don't need these. So that's one thing we can do. We just grab the index and row directly out of this element. We don't need to keep that separate element variable here. All right, this one is pretty straightforward. I guess we could pack this directly into here. We don't need to have this element. And then we still want this compare, and this, see how our index and row are just n0 and n1? We could replace those here. All right, so we've eliminated a bunch of our sort of helper variables, and we've compacted our code quite a bit. Let's see if this helps. I kind of think this might not even help us. Actually, it does. So we go from a 95% for runtime and 94% for memory to, actually, what? No, it's exactly the same. It makes no difference. Whoa, that's crazy. Oh yeah, it makes a difference for our memory. Okay, that makes more sense. So we went from a 95.7% for runtime and a 70% for memory to a 95.7% for runtime and a 94% for memory. So by eliminating these helper variables, we reduce our memory footprint. However, it's your choice whether or not you want to do that. Those helper variables actually make reading the code a lot easier. All right, well, that is it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.